So let's fast forward to some of these other molecules, because this story is just so interesting, and feel free to go back and patch pieces of history if it makes things to where we are today. But today we are in a place where there are two companies out there that are selling NR, precursor to NAD. They're packaging it with, is it pterostilbene?
Right.
Tell me what that molecule does specifically and why it would make sense to include that with NR.
Yeah, so pterostilbene is essentially just resveratrol with some methyl groups on it. It's a more novel, sexier version of resveratrol, but that's the...
But is it any more active, in your opinion?
So Lenny has told me that it is, but I don't know enough to be able to give a sensible answer.
Okay. So you now have a SERT activator with an NAD precursor that are both basically over the counter, right?
That's right.
So tell me about the excitement in that space. I don't want to get too much into the politics of the companies, because they're, at the time of this recording, they are in World War III. So let's just talk about the science and not sort of all the other stuff.
Yeah, well, if you take the 40,000-foot view of this, so Lenny is in his 60s now, and I'm in my 40s, very late 40s. And you got to do a calculation. How many years do you have left to not only see what happens, but potentially even be vindicated? And I'm sure that's part of Lenny's thinking.
What would Lenny be vindicated for?
For finding that the sirtuins are important for health, longevity in humans.
Oh, I see. Meaning that following this discovery, some of the air left the balloon, and now there's a resurgence of, hey, no, it really did matter. Is that what you mean by being vindicated?
Well, I think there's a race to see whose pathway is more important.
Got it.
And the sirtuins and mTOR and AMP kinase and some others are in this race. I think it's a silly argument because they're all important and they talk to each other.
Yes.
But ego is involved and people want a legacy. And Lenny's legacy, as I understand it, can't speak for him directly, but is that he wants to have made a major contribution to human health. And this is a way of showing that within a time frame that's reasonable. Who wants to wait another decade? If I was him, I wouldn't want to. And so I think that was a good way of being able to quickly test the hypothesis in an area that, going through the supplement route. On the other hand, I think because I'd had the good experience with pharmaceuticals and I also have more time to wait, I took that route. And so the two of us are heading in parallel. We're very good friends and we talk all the time about this, but it's an interesting, from an historical perspective, that we got these two guys who are taking very different routes to what we hope is achieve the same thing, which is to help people in the end.
And Elysium, obviously they've talked very publicly about their goal is to sort of provide a supplement, but at a much higher quality. Obviously in the United States, I can't speak to this in other countries, but the regulatory environment here is quite unique in that basically these supplements are quite unregulated. So you're sort of at the mercy of the person who's making the supplement. And obviously having a number of Nobel laureates involved with a company like Elysium and a public commitment to use the highest quality stuff, at least a person can buy this and say, look, I'm not getting crushed bird feathers, which I'm pretty much guaranteed to be getting with half the stuff I buy online. Look, I bring this up because I think half my patients are either taking Elysium's basis or I can't remember the name of the other company, Chromadex, is it the other? Yeah. Half my patients are probably taking NR. They always ask me, what do you think? To which I say, I have no earthly clue. I'm pretty sure it's safe. So that it passes the first test, which is I don't think it's hurting you. One of the issues I've always struggled with is if it worked half as well as it works in the mice, it shouldn't be subtle. You showed in one of your talks a contrast between two mice running on a treadmill. And that was actually one of the milder successes. That was like, a 50% improvement in exercise tolerance. I've seen other studies that talk about an 80% improvement in exercise tolerance. If people were experiencing a 20% improvement in exercise tolerance, I believe we'd know about it. Do you feel that that's happening and we're missing it? Or do you feel it's just not going to be possible to elucidate that without a clinical trial, even though it's a supplement?
I get a lot of emails every day.
You might be the single most emailed person on this topic, I'm guessing, right?
Yeah.
Wait till your book comes out.
Probably 1,000 of them this week, actually, and I'm not exaggerating. And to any of you who've written to me, I'm sorry, I just can't answer them all. I will try. One of the main questions is...
Well, hopefully by having this discussion, let's go as deep as you want into it so that you can say, go listen to that discussion and you'll get all your nuanced points across.
Yeah, or go buy my book. But
even better.
That's coming out next year in 2019.
Do you have a title for it yet, by the way?
It's a tentative title.
Okay. So at the time of this recording, for people listening, we don't yet know the title, but David's book will probably be out in the late summer, early fall of 2019.
That's right, Peter.
Okay.
Yeah, so I have some insights into this NAD world as it's developed. It's extremely hot. They're selling tons of the material, which is great if it helps people. Now, I get a lot of emails from people who claim, and they show me data that they used to do races when they were 40, and then now they're 60, they can't win races, they can't cycle, but they've gone on this or that NR product or even NMN, and now they're winning races again. So these are stories I hear constantly, every few days. But I can't judge those because these are people I don't know, there's no placebo. But I think that some of this, if it were true, that's what we would expect. If these molecules could help people, you would hear these anecdotes, which I hear. But I can't declare that I know anything more than you do, Peter, about this, because they're all anecdotes. So that's why we're doing a human clinical trial.
Now, you mentioned NMN a moment ago. Can you tell us, listening to this, the difference between NR, nicotinic riboside, which is a one-step precursor to NAD, and NMN?
Well, it's very simple. So NR is converted by the body into NMN, and then NMN is immediately converted to NAD. So those are the steps.
Oh, so I misspoke. I actually thought it was NR that was one step away from NAD, and NMN went to NR, but it's the other way around.
Correct.
Okay. Both of these we know definitively both of these can be brought into cells to be used as cellular building blocks for NAD. Is there any dispute about the ability to get from high plasma levels into the cell?
Yeah, there's a debate. It's not earth-shattering, it's very academic, but yeah, we're debating in the field about which molecule gets transported and which one doesn't. And NR definitely gets transported. The question is, does NMN get transported?
And I believe you've written I think I read in one of your review articles, perhaps, but it could have been somebody else's, that NMN might be slightly more stable than NR.
Well, we find that in the lab, that if we put them in solution on the bench or leave them on the shelf, that NMN is more stable than NR. That's why I keep my molecules and labs molecules in the freezer, just to give them some extra shelf life.
And did you imply by what you said a moment ago that there is no dispute that NR at least gets, if you have a high plasma level of NR, it is brought into the cell? Is that diffusion mediated? Is that transported?
There's a transporter for NR. There's evidence that there's an NR transporter. But either way, they both raise NAD levels quite effectively in the body, in humans as well. And
I'm sorry, I know I asked this already, but when you say they raise NAD levels, you mean mitochondrial NAD levels or cytoplasmic NAD levels?
Oh, gee. So most of these studies have been done on whole cells from blood or tissue.
So they're just like PBMCs or something like that?
Exactly. The problem with that is that it's a very dynamic system. This isn't a regular drug that just hangs around and you can measure it. This is actively utilized by the body. So even if it disappears into some pathway, it's still probably being recycled. So we have to be very careful not to jump to conclusions. If you don't see it in the blood, maybe it was taken up by the muscle or the brain. So these are the studies that are ongoing now.
And if you see
academia.
it in the PBMC, it doesn't mean it made it into the hepatocyte.
Right. This is all just, in an animal you can do that. We're starting to do those experiments in humans right now using NMR to be able to measure NAD levels in the living tissue.
And when you say NMR, do you mean like MRS or like?
Yes.
Okay.
I do. So phosphorus, MRS.
Yeah.
And you can measure ATP and AD.
Right.
So those are really powerful, and you can actually now do it with 7 Tesla magnets with people in the machine while they're exercising. So that's where we're headed with this in our next clinical trial, hopefully.
In your intuition, David, if you could cherry pick the hierarchy with where you'd want to see the upregulation of NAD most, which cells would you preferentially be directing it into?
Well, it depends on if we want to treat a disease, obviously we've got to target that particular tissue. So if we're treating a mitochondrial disorder of the muscle, obviously the muscle. For longevity, I would want it to definitely get into all tissues if possible. I think it would help if it could get into the hypothalamus, where there's some central regulation. But what the field has discovered is that all these tissues, not all, but many of these major tissues, are secreting proteins that can induce longevity. So I wouldn't want to prioritize unless we're talking about a particular disease like liver disease or muscle wasting.
One of the things David Sabatini and I talk a lot about, I'm actually going to see David for dinner tonight, and I'm sure this will come up, is if you could wave a magic wand and make rapamycin, for example, tissue specific, let alone complex specific, but you get into this. And the same thing with metformin. It probably does have some tissue specificity, probably working more in the liver than it is working in other cells. It seems unlikely that a molecule would have uniform and ubiquitous take-up of all cells, right?
Well, of course, yeah. So with NAD, we don't know.
So we're basically still in the infancy of knowing where the NR or NMN would be preferentially taken up. But it sounds like the MRS studies would help us understand that.
So that's going to help. And the reason I qualified that statement was that, we're still getting approval for these studies, but that's the plan. But also there are labs that I'm aware of who I think shall remain nameless as well to protect their own confidentiality, but they are working on tracer studies to be able to give NR, NMN and see where it goes in the body and be able to measure each tissue. That we'll know probably within the next 6 months to a year.
So you mentioned that what Elysium or Chromadex are doing is they're just basically in a different regulatory paradigm, which is they're using molecules that are generally regarded as safe. They're outside of these IND pathways. You're interested in the same sort of targets, but you're going to go down, I don't want to say more rigorous but it is more rigorous. Let's call a spade. You're going down a much more rigorous
It's
pathway.
more expensive, that's for sure.
Yeah. I mean, literally 2 logs more expensive, if not 3 logs more expensive. So I want to be sensitive to any confidentiality because that's the nature of the work that you're doing now. But what can you tell us about the molecules you're working on directly and indirectly in that space?
Sure. In the NAD space, there's a couple of companies. One is, I can divulge, is called Metro Biotech, which is here in Massachusetts. And they've been working for 5 years on making NAD precursor molecules that are better than these 2 that are available publicly. And there are ways to improve them, better bioavailability, better stability, better efficacy. And those are moving into the clinic as well. And then there's another company called Jumpstart Fertility, which is both here in Massachusetts and down in Australia. And we're finding really great effects of these molecules on female infertility or low fertility. And that's something we're going to be publishing shortly.
And is there a type of infertility that this seems most amenable to? Because going back to your evolutionary argument, under periods of stress, we see fertility as one of the first things to go for obvious reasons. But infertility comes in so many flavors, right? There could be an inability to release an egg. There can be aneuploidy even when the eggs are secreted. There can be uterine hostility. There's so many things that can result in infertility. What does this particular thing target?
Well, so what we find the biochemical pathway we've figured out, and we've published a little bit on this, is that there's a protein called BABR1, which is a kinase that regulates spindle quality. And one of the problems with old eggs is that they don't have nice spindles and they rip their chromosomes apart when they form
Hence
an
the
egg.
aneuploidy. Exactly.
So Down syndrome, etc., aborted fetuses. But what we found is that this BABR1 is regulated by the SIRT2 protein, which requires NAD. And what we think is going on after chemotherapy or during aging is that the levels of NAD in the ovary and in the egg are low, and it's getting this aneuploidy. And that explains why when we give NAD precursors to eggs in vivo, the eggs come out healthier, more numerous, and are much better at allowing for fertilization and healthy offspring.
I don't know much about fertility, as this next question will illustrate, but presumably you can still see aneuploidy on the male side. So is there a male fertility opportunity here as well? I realize it's not probably as common a problem, but presumably you still have to have a perfect split of the chromosome in the sperm.
Yeah. Possibly. It's an area that we're looking into. I don't have anything solid enough to be able to say if it works or not, but in theory, yeah.
And just going back to something earlier, is NMN available over the counter?
It is. More recently, I can see it on the internet.
Okay.
But one of the things that I want to bring up is you can find my name all over these products. Not basis, they're reputable, but there are others that use my name all over the place.
Meaning without your permission?
Correct, and Harvard's permission. And so I've sent more cease and desist letters than you can imagine. And they keep popping up.
So that's an important point. So if a listener after this talk is saying, hey, David Sinclair sounds like a smart, reputable guy. If his name's on something, I should take it. What can your name be associated with right now that is, with your permission?
Nothing.
Okay. So basically anything that's out there that's over the counter that has your name on it is not endorsed by you.
Correct.
Okay. Thank you for clarifying that. That would be frustrating.
Yeah, it is, but I try to stay above the fray.
It's nice when you can stand on Harvard's shoulders and let their lawyers send those cease and desist letters.
It would be nice if that were true, but I spend a portion of my salary every year on this.
Really? That's a shame. I'm sorry to hear that. So fertility is a super interesting angle. I would have never thought about that. That strikes me as highly testable as well, which, one of the challenges of longevity research, as you know better than I do, is if you want to make claims in humans, you better buckle up, because it's going to be, it's almost untestable. So when you look at what other companies are doing, like Restore Bio going down the mTOR pathway, they're not going after longevity, right? They're going after very, very specific indications that are testable in shorter periods of time, respiratory failure, things like that. What are the other disease states that you think would be most exciting if you don't already have plans to go down that from your pharmacologic standpoint?
Well, we've been targeting diseases that are rare and have a high unmet need. So I can't divulge all of those because that's company stuff. But the fertility part, that's very clear. I'm able to tell you that those trials will begin next year in IVF clinics, and that will be the first time a doctor looks at those eggs from a woman, she'll probably know that it's working or not. So that's very clear.
And when you say company, we're sitting right now in a headquarters that is the name of, what's it called? Is it Life Bioscience?
Yes.
And that's a parent company, or sort of, tell me how that fits into a number of the scientific entities that you're involved in.
So Life Biosciences is a family of companies that uses shared resources and knowledge. There are 8 of us right now that work on different aspects of aging, not just NAD biology, but the usual suspects, all the major hallmarks of aging that we could list off. Each one of these companies has world leaders and drug development programs in that, so that we think we can, quote unquote, conquer aging from different aspects, but together we're stronger as one unified company, Life Biosciences.
Earlier you spoke about sort of 8 or 9 central tenets of aging. We've covered some of them, but I know, and I'm guessing that your book is going to go into this in greater detail, but can you rehash what you, or at least as many of those as you're going to recall on the spot? Not to put you on the spot, that's a long list.
Yeah, sure. There's epigenetic change, there's cells-to-cell communication and inflammation. There's senolytics, so senescent cells build up. There's protein misfolding. There's telomere loss and genomic instability. There's metabolic changes, so AMP kinase and metformin would address that. And then there's responses to amino acids and other nutrient inputs. And those collectively go awry during aging. But what causes all of those to happen? That's something that we've been working on for quite a while.